Hi everyone, welcome back. In today's episode, we'll be diving into how to use the Tunny library in Golang. If you're working on concurrent systems where tasks need to be processed in parallel, managing resources efficiently is critical, and that's where a worker pool comes in. Let's explore how Tunny simplifies this process. Tunny is a Golang library designed to manage worker pools. It allows you to control the number of coroutines running simultaneously, which helps optimize CPU usage and prevent excessive memory consumption. By using Tunny, you can easily delegate tasks to workers and track their execution. Let's install this first. Copy this command. Let's run this command to complete the installation. Let's understand how we can use the Tunny package to process tasks concurrently. We can simulate sending emails while limiting concurrency to the number of available CPUs, ensuring efficient resource utilization. Let's begin. This function simulates sending an email. It takes email, subject, and body as arguments. Here, it prints the email details to the console. Then we simulate a delay of 2 seconds to mimic email processing. Now let's see how we can use Tunny to send mails simultaneously. Inside main, we determine the number of available CPUs using runtime.num CPU. Let's print this number. This number will help us configure the worker pool size. We want to run 1 coroutine per CPU. Here, we create a worker pool with tunny.newfunc and we pass the number of CPUs as the pool size. Each worker executes this function. It expects a payload of type interface and returns an interface as well. We assert that the payload is a map of string key and interface value. If the assertion fails, return an error. Extract the email, subject, and body fields from the map. Validate that these fields are of type string. Once the fields are validated, we call sendEmail to send the email. Finally, return nil if the operation succeeds. Just after the pool definition, we defer the closure of the pool. Now, we will simulate the scenario where multiple programs or coroutines use the pool to send emails. Let's loop 100 times to generate dummy email data. We will use a map to pass the data to the pool. Here, we construct an email address using the iterator I. Next, in the coroutine, we use pool.process to process the email in a worker. Here we pass this data, which is a map. This is passed as payload to the pool definition to this function. If process returns nil, the email was sent successfully. We print confirmation. This piece of code monitors the pool queue and provides a grace period to provide enough time for the coroutines to complete. Here, we get the queue length and print it. If the queue length is 0, we break out of the loop. We sleep for a second in the loop. This is the grace period for the running goroutines. Let's run this program. We can see from the length of the queue that 8 goroutines are running in parallel. Once the queue length is 0, the program waits for the goroutines to complete. Concurrency allows multiple tasks to be performed simultaneously, but managing the state of these tasks can become challenging. Let's jump into an implementation that can help you manage states on per-worker basis. We define this struct myWorker. This represents a single worker in the pool. It has job ID that keeps track of the job being processed, and the state which reflects the worker's current status, like starting, processing, interrupted, terminated. You can application-specific states as well, like this. We will paste a few methods for this struct to save time. We need these methods to implement a custom worker using Tunny pool. The process method is invoked when a worker is assigned a job, extracts the job ID from the payload, sets the worker's state to processing, and logs it. Simulates processing with a 2-second delay. Returns nil to indicate success. The block until ready function is called before the process function is executed. It sets the state to starting, then simulates a brief setup delay before the worker is ready. The interrupt function is called when the execution of the worker is interrupted. It sets the state to interrupted. When the worker is terminated, this function is called. This sets the state to terminated. In the main function, first we get the number of CPUs like before. Let's create a worker pool using the Tunny.new function. The number of workers equals the number of CPUs. The second argument is this function. It returns an instance of myWorker. We return each worker is an instance of myWorker. The defer pool closure to ensure the pool is shut down when the program exits. Now we will dispatch the jobs to the pool. We loop over 10 times. In this goroutine, we submit a job to the worker pool. Each job is represented by its index I in data as an interface. Then call process that assigns the job to a worker. If process returns nil, the job was successful. Otherwise, it failed. Just like the other program, we monitor the queue and add a grace period. Let's run the program. Here we can see different jobs and their states are being printed. In the end, when the program completes, the workers in the pool are terminated. That's it. By using Tunny, we've seen how to manage concurrency effectively in Golang. You can control the number of workers, distribute tasks, monitor the queue, and even maintain worker states. This makes Tunny an excellent choice for tasks like email sending, file processing, or any batch job. If you found this video helpful, don't forget to like, subscribe, and leave a comment below. Let me know how you're using Tunny in your projects. Until next time, happy coding.